This is the number of people times the average value that you joining brings them. And this says price equals marginal cost minus the externality. That's exactly what we studied in Pigou. So this is just Pigou's formula. That's the social outcome. Now, the monopolist is going to distort versus this in two ways. So David Hampton, can you tell us what the monopoly formula is going to be like and the two ways in which it differs from the socially optimal?
I imagine there'll be some sort of markup. So
Where's that?
that's the n over m.
Yeah, that's mu.
And so the price is going to equal its marginal cost plus some markup plus the externality from extra users.
Except what's the externality term going to look like? So here it's NU bar. Is it still going to be that for the monopolist?
I can't think that would be different.
Well, so remember we said that the monopolist always cares about the preferences of the marginal consumer.
Okay, so it would be the externality to like the marginal user, so like the next.
Exactly. So there's two distortions. Price equals marginal cost plus there's this markup. But then minus, rather than the externality to the average consumer, it's the externality to the marginal consumers. Right? So there's two distortions. There's the Cournot distortion and there's the Spence distortion. Both enter into your choice of the number of people. And so this may go in either direction. So think about a newspaper, right? You know, I don't know if many of you guys read the New York Times, but probably a lot of people in Chicago are what I would call inframarginal readers of the New York Times. They're going to read the New York Times every day, even if the price went up by a lot, right? And most people like that really don't like ads. They find them really distracting. Whereas many of the marginal readers of the New York Times don't care that much about ads. So that, in that case, the inframarginal people dislike ads more than the marginal people do. And that would mean that the Spence distortion would actually lead to too low of a price for ads, right? Because you don't internalize the distaste for ads that the inframarginal consumers do. And that would actually offset the Cournot distortion, which is always, it has a tendency to raise price. So in that case, actually having market power over the advertisers is a good thing. Credit cards, right? Someone who loves using their credit card is going to value having an additional merchant accept that credit card a lot more than is someone who doesn't really care whether they can use credit card or cash. And so in that case, the market power they have over the merchants is going to be really bad because it's already having too few merchants accept the cards. And now it also has market power, so that's reducing it further, right? And I think the thing that's interesting about platforms is, you know, we were talking earlier, I don't know, I think it was maybe Edward that said it, that firms often, you know, in order to cater to different consumers, offer different levels of quality. But that's really hard with a network, because it's not like you're going to deliver different newspapers with different selections of ads to different people. Now on the internet, maybe that's a little bit easier, but at least traditionally, that's not really what happened. It's not like some people can use their credit cards at more stores than other people can use them, right? So because it's really a single product, the Spence analysis is really relevant. Okay, so in most cases, as I was alluding to before, there are multiple different distinct groups of consumers. There's not just one undifferentiated group, and these are often called sides of the market. So we could note those I equals A, B, etc. Readers and advertisers, card holders and card acceptors. Now, I didn't go through the math for that case because there's just a little bit more of it, but basically the ideas are exactly the same. The socially optimal thing is to set the price to each side equal to the marginal cost minus the sum over all the sides of the number of people on that side times the average externality to bring them. And the private optimum has two distortions. There's a markup to this side, the Cournot distortion, and then you internalize the value you bring only to the average marginal consumers on the other side rather than to the average consumers. Yeah, Andy?
Then in multiple dimension platforms, where does the network effect come
So it's like, the newspapers are more valuable to the advertisers if more consumers read them. That's the network effect. So that would be the effect, that would be the average marginal utility of an advertiser for an additional reader. Right? Yeah?
Yeah, so like the line equation says externalities average users, right? And we
Yep.
subtract it from marginal cost. But
Yep.
I just had a quick question.
Yep.
Does that matter whether that externality is a positive externality or a
Yeah, so I'm denoting it with the convention that this is a positive externality because this is the marginal utility that these guys get. That marginal utility could well be negative. So you'd actually want to raise prices to advertisers if they annoy consumers, right? Okay. So, in that model, users cared only about the number of other users, not about which other people were using the platforms, right? But in many cases, it's really important to try to attract the right types of other users, right? So one classic example of this is soap operas. So why are soap operas called soap operas? Well, because they were used to sell soap to women in the 20s and the 50s, right? And the idea is that they were made really melodramatic because that would be particularly appealing to the people who had control over the family's purchasing decisions of soap, who mostly tended to be women. American Express has all these travel services it offers, and offers points to try to attract people who will use their card a lot so that they can make money off of the merchants where you use the card, right? So clearly the sort of big spenders and the women are much more attractive to the platform than are the men and the lower spenders, right? And this shows up in lots of contexts, not just in platform context. So if you think about how an insurance company sets the level of coverage it's going to offer, it doesn't want to attract too many people who are really sick who might be attracted by very comprehensive coverage. Or when companies require down payments on a house, they don't want to attract people who are bankrupt and therefore can't afford to make a down payment, right? And so in this sense we can say different users can make heterogeneous contributions to the value of the platform. And so a primary role of the instruments now is going to be to try to sort out which are the good consumers and which are the bad consumers, right? So the simplest model of this is that each user generates some characteristic, K, which depends on the type of that user. And each user now has a utility which depends on the total amount of the characteristic generated and their type, and the platform's cost depends on the number of people. So the characteristic is now going to be the integral over everybody, not of just how many people there are, but of how much of the characteristic they're generating. So some people are rich, some people are poor. If you're rich, this is big. If you're poor, this is small, or something like that. Or some people are beautiful, some people are ugly. At a dating club, this might be, high if you're beautiful and low if you're ugly, right? So in this case, users are heterogeneous both in terms of their preferences, how much they care about the characteristic, and in terms of their contributions, how much they add to the characteristic, right? And the key is the relationship between these two things. So that's what we're going to focus on. Again, we're going to keep a bunch of the same quantities we've been talking about so far. The number of people participating, the number of marginal people, the market power, the average value, the average marginal utility of a marginal person for a bit more of this characteristic, and the average marginal utility of an average person for this characteristic, right? But there's going to be, and also we're going to denote the average value of the characteristic brought by a marginal person by K tilde. But the key new quantity is going to be this thing, which I'll formalize a little bit more in 1 second, but it's the covariance between people's preferences and their contribution, given that they're marginal to participating or not. That is the key quantity. Okay. So, Clementina, how could we make that just a little bit more precise? What would be a measurement of people's preferences and their contributions?
Well, everyone's preference will be that the quantity is really precious. Or you can measure how much they take or
Sure, or how have we been measuring how much people like something so far?
is there a number in the pipe?
What?
Based on the number and the quality and the price?
Well, so we've been talking about people liking things by thinking about their marginal utilities, right? So one thing we could substitute in for preferences is the marginal utility, right? And how about for the contribution that they make?
The marginal cost that they,
Well, we have this marginal contribution that they make to the characteristic, right? So to formalize this notion of a covariance between preferences and contribution, given that you're on the margin, we can have this expression. Sigma is the covariance between marginal utility and your contribution, given that you're on the margin. And this is the crucial quantity that we can use to understand all these things. So let me show you why that is. Okay, so what happens if we increase the number of people, right? Well, just like we had before, that's going to reduce the price by -1/m. And it's going to increase it by people's average marginal utility times how much the characteristic increases when n increases. Okay, well, how much does the characteristic increase when n increases? By the same argument we were using before, it's going to fall because the price is going to rise by something related to change in price. And it's going to rise based on the direct effect of increasing the number of people. So how much does the price rise? Well, we can just solve this equation out, right? So when we increase the n, we're going to change the price, and we're also going to change the characteristic. How much does that in total change the characteristic? Well, it's going to lead it to fall by the number of people on the margin times their average marginal contribution times the amount that the price changes. And it's going to rise by the number of people on the margin times the average of the product of their marginal utility and the characteristic along the margin times the amount the characteristic changes. Why is that? Because we just had to use Leibniz's rule, right? We brought the marginal utility in from the outside, and then we have the average value of the product of these things. So if we bring this through to this side, right, we get that, or sorry, if we substitute this into here, we get -1/m times this, so that gives us plus k tilde. And then we get this term times that, so that's dk dn times u tilde prime. So what that gives us is m times the difference between u prime k tilde and u prime tilde times k tilde. What is that? That's the difference between the average value of the product of u prime and k and the product of the average value of u prime and the average value of k. And for those of you who've taken a statistics class, you'll know that the covariance between two variables is the difference between the expectation of the product and the product of the expectations. That's a famous result in statistics. So you can just take the difference between these things, and we can call that the covariance. And so what does that give us? Well, the derivative of the amount of characteristic with respect to n, this expression up here, is equal to the k tilde plus m times sigma times dk dn, right? And then we can just bring these terms over here and factor this out, and that's going to give us dk dn is equal to k tilde over 1 minus m times sigma, right? Or that when we increase n, the price is going to increase by -1/m plus k tilde times u prime tilde over 1 minus m sigma. So the basic reason why this happens when we increase